Now that we know about the different types of numbers, we need to talk about how to classify them. So I'm going to use this as an example. We have this model and we have all of these different labels, mammal, carnivore, and dog in there. So I have a dog named Penny Lane. So I'm going to write her in this dog box. So do you think that since Penny Lane is a dog, that she's also a mammal? Well, the answer would be yes, because she is also inside the mammal box. So if you look at these boxes, they nest inside each other. So Penny is a dog, which is also inside of the carnivore box, which is also inside of the mammal box. So she belongs to all three of these boxes, but I only have to write her name one time because of the fact that she is inside all three of them already. So if we have an animal that's a carnivore, are they also a dog? Well, no, because you can be inside this carnivore box, yet not be inside the dog box. But if you're inside the carnivore box, that means you're also a mammal, right? So if we were to think about a lion, well, we would write that lion inside the carnivore box, but not in the dog box. But as you can see, that lion also sits inside the mammal box. So the lion is a carnivore and a mammal, but not a dog. The number system that we use classifies numbers based on their type and characteristics. And we use models much like the one here with the dog. So let's think about the numbers that we discussed. The box all the way inside and smallest, this would be our natural and our counting numbers, right? They mean the same thing. They would be this smallest box inside. The next box would be our whole numbers. If something belongs to the natural counting numbers, it also belongs to the whole numbers. The next box is going to be our integers. If something's a natural number, it's a whole number and it's an integer. The largest box is going to be our rational numbers. If a number belongs to the whole number, of course it can also be an integer because those boxes sit inside each other. So now that we understand how the number systems work, let's go ahead and let's classify these numbers. We're going to use abbreviations though. If it's a natural number, we're going to write an N. If it's a whole number, a W, an integer, an I, and a rational number, an R. So let's think about the number 24. Would it be a counting number? Would it be a natural number? Absolutely, because we would count with it. Well, think about if it's a natural number, that means it's automatically going to be a whole number and an integer and a rational number. What about negative 12? Would we count starting with negative 12 or using negative 12? Would we say there are negative 12 students in my class? No, so that means it's not a natural number. It's not a whole number because it's negative. Whole numbers have to be positive. It is, however, an integer because it is a negative number that is the opposite of a whole number. And it is rational. Since it is an integer, we know it's rational. Well, this next number has a decimal. Since it has a decimal, there is only one classification it can be, and that would be rational. Now, if that decimal went on forever and didn't have a pattern, then it would be irrational. But this decimal terminates. It ends at 5, so it's rational. We have a fraction here that cannot be simplified into a whole number or an integer, so that means it is rational. The number 7, well, that's definitely a number we would count with, so that means that it's natural, it's whole, it's integer, and it is rational. Now we've got to take these numbers and place them where they belong within this model, but you'll notice that the natural numbers is missing. So that means we've got to just start with whole numbers. Negative 9. It's negative. It doesn't have a fraction or a decimal with it. So that means that it is an integer. 0 would be a whole number. 1/8. We're not able to simplify that into a whole number, so we have to keep this fraction as it is, which makes it automatically rational. 1/2 cannot be simplified into any other type of a fraction, and it's negative, so that means that it also has to be a rational number. 15, well, that's going to be a whole number. 126, it's another whole number. -37, it's negative with no fraction or decimal, so that means it has to be an integer. 2/3, well, that's a fraction. It cannot be simplified into a whole number or an integer, so that means it's rational. Let's look at this last slide. Our job here is to figure out if the numbers have been placed correctly or not, and then tell us why they are wrong. So let's start with -1.0. Well, I see that it's right here in the whole box, which is incorrect. This should be an integer. It should not be in the whole box because it's negative. So I'm going to go ahead and I'm going to add this to the integer box. Well, 10/5 really means 10 divided by 5, which is 2, which would make it a natural number. It's in the right location. -7.0 would be an integer, and it is in the correct location. So far, these two have been good. -8.5, we have a decimal. It's terminating, it ends. So that means it has to be a rational number. But look, they have it in the integer box. That's incorrect. It should be in the rational. So we're going to label that no, that it is rational because it has that decimal. -9.7, that one's good. It's in the rational box. 3/6 simplifies into 1/2, but then 1/2 does not become a whole number or an integer, so that means it has to be rational. And sure enough, they've got it in the right box. 3/4 is a fraction that cannot be simplified into a whole number or an integer, so that means it has to be rational, and there it is. -8/2 is really saying 8 divided by 2, but it's going to keep its negative sign, would make it -4. So that means it would have to be an integer. But look, it has it in the rational box. That's incorrect. -8/2 should be an integer.